Hello guys, I'm Liviu and welcome back to my channel. Today I'm gonna do a teardown and deep dive into the air unit from DJI. I'm gonna go over its design, what I think about it, but let's start slow and see where we end up to. I received this air unit from Daryl Bleach, and thank you very much, man, for donating this broken air unit. I received this air unit already disassembled. The air unit has two main PCBs. One has all the radio frequency stuff and SD card, and the rest one has all the power and processing stuff on it. They are connected together via a flat flex cable, and this is how they connect each other. This is the one where you plug in your USB and the connections to the outside, powering the unit and so on. Daryl said to me that this one was broken due to reverse polarity, but I doubt that pretty seriously because DJI thought to include a very serious reverse polarity protection. I will talk about it later, but on the radio frequency part, which is this one, we can see a lot of water damage. And first thing that gives away a water damage on DJI system is this special paper here, and if you look at it, it's red. It was supposed to be white, so if water gets inside an air unit, DJI would definitely know that it was water damage. And we can already see some corrosion remains here. Also on this side we can see a lot of water damage around this section. Luckily inside there is no obvious damage. This is the radio frequency section, and this came as a surprise to me because I didn't expect to find here dedicated chips for Wi-Fi. I struggled a bit to find some information about this radio frequency transceiver, and I think I finally found what this chip is. It's made by Imagination, and the chip is IMG IE1000, and this is a Wi-Fi ready solution. After that we have lines going to some front end modules, and we already see that we have some unpopulated footprints here that looks identical to the front end modules. The front end module is from Skyworks 85743-11. It's a 5G front end module that has inside low noise amplifier for receiving and a high output power amplifier. I don't know exactly what output power this does because there is no public datasheet, just a basic information sheet about this front-end module, but I suspect somewhere around 30 dB, and that's around 1 watt. I know there is a special mod you do for DJI for 1.2 watts. I don't know what to say. I asked Skyworks for a datasheet on this module, and if I find something in the future I will come back to you with some information. But basically all this configuration here is Wi-Fi ready, and I don't know what DJI did with this. Maybe they have a special firmware that makes this transceiver do other type of modulation techniques. So yep. Funny thing is that on DJI drones I found exactly the same front-end modules. So back on the main board, as you can see, we have the connector, we have the USB, and we have here a pretty common looking device for all you FPVers out there. This is a MOSFET. It's not an N-channel MOSFET like you would find in everyday ESCs, but this is a P-channel MOSFET. I'm most definitely sure that this arrangement here is related to the reverse polarity protection that DJI designed for the air unit. I'm not 100% sure, but nothing else is close to this MOSFET. That means inductors or such. So I believe this is what they did, a P-channel MOSFET. a 30 volts channel MOSFET actually that can be used as reverse polarity protection, so that's pretty neat actually. Let's turn it on the other side and talk about what we can find here. So I'm gonna start from this section here because it's the most important thing. We have two regulators from TI. This is 54335A, and we have another identical IC here, and we have its corresponding inductor here and here for this one. These two are the ones connected straight to the voltage input. They can accept a maximum of 28 volts input. That means that at least in theory this air unit is capable of working on 6S, but don't blame me if you break something. But at the end of the video I will try and power this on 25 volts and see what happens, but only after I will remove the culprit and the killed part on this air unit. So we have these two regulators. One of it most definitely sure makes 5 volts, and the other one I suspect it's making 1.8 volts required for the radio section, or at least this is what I'm supposing. And here we have the power managing IC. It's actually an IC that has inside multiple regulators, LDOs, 4 switching regulators and 4 LDOs if I'm not mistaken, and you can set up different voltages on all this. This is working with 5 volts, and here we have the magical unknown processor. Most definitely is an system on chip that can handle video processing. An FPGA, I highly doubt that DJI produced their own silicon. This is a Micron NAND and RAM. It's a 4 GB NAND and 4 GB RAM. It's a DDR3 if I'm not mistaken. So yeah, nothing out of the ordinary here, to be honest. A pretty straightforward solution. The PCB obviously is very good quality, the design also. Unfortunately, this system on chip or main processor, however you want to call it, it's busted. It's getting up to 110 degrees in the first 10 seconds or so. I have no reaction from it, so most definitely something happened with this processor while the air unit was in contact with water. So yep, be careful what you do. If you know that your gear can get into water, I will highly suggest you to do conformal coating on it, but be very careful what type of conformal coating you choose, because some of them are temperature sensitive and they melt out when hot, so it's pretty difficult. The Mavic line of drones at least have water protection from the factory, and also the BGAs have here some type of very hard glue protecting all the balls under the chip, so no water can get underneath it. And to test my theory that the air unit can handle 6S, I will have to take out this bad processor, because I have a pretty erratic current consumption going up to 2 or 3 amps, which is not okay. I just hope I have enough power in the hot air. It's the first time I'm trying to desolder a BGA so big. So hopefully we can heat it up at the right amount and take it out and see what's up. So I have my temperature set up almost to the max, but not the max. These PCBs have so much mass inside, copper mass, and we need a lot of power to take it out. Okay, messed it up a bit. Hopefully I can take it out. Yeah. So this is how ball grid array chip looks like underneath. A ton of little connections, little balls of solder that connect the parts to the actual PCB. So let's clean a bit all this nasty thing from here. I'm using some fresh solder to try and take away all this lead free from there. It's funny how this thermal compound got there underneath the IC. Okay, let's place some flux, some solder wire. Okay, and now let's clean a bit all this mess and hopefully leave cleaned PCB. So I cleaned as much as I could here. I have no bridges or anything. I connected one connector here to be able to supply positive and negative to the board. So let's see. Yep, as I've imagined, I have 20 milliamperes of current draw because, well, right now I only have the regulators and the NAND, which most definitely is sleeping right now. So I opened up the datasheet for this power management IC that controls every voltage that the CPU gets, and this is the one. And I want to see which pin is responsible with the input voltage so that I can probe that voltage. So we have like so, pin number 1, 2, 3, 4, 5, 6, and we have pin number 1 is V input 1 and pin number 6 V in number 3. So if I'm going to probe the ground and pin number 6, I have 3.3 volts. Pin number 1, 3.3 volts. And where do we have more inputs? This is one input, 3.3 volts, and this is another input, 3.3 volts. The power management IC is working with 3.3 volts, and if I'm not mistaken, first regulator is responsible with the 3.3 volts, but let's see. No, that's 5 volts, so this one is 3.3 volts. Yep, 3.3 volts, but 3.3 volts with a lot more current because the inductor, well, it's way bigger. So we have 3.3 volts here, 5 volts here. And this power management IC most definitely creates a lot of other voltages as expected. 1.8 volts, 0.9 volts, and what we have here, 0.9 volts, 1.2 volts. So we have 1, 2, 3, 4 and 5 voltages present on this board. Okay, now let's try and power everything from 25 volts as I've said previously because I suspect that this board can handle up to 28 volts, so 25 volts is the 6S voltage. As expected, the board works flawlessly on 25 volts, but these two regulators, which are the first taking contact with the input voltage present at the connector, are rated up to 28 volts. So if spikes are present, these two would not handle it for sure. And as you can see here, we have our MOSFET I was talking about. This is a P-channel MOSFET. This most definitely is a Zener, and this is the gate circuit. This Zener actually is to protect the transistor gate because it has a limit of voltage on the gate. So this Zener here is just to protect the gate. This MOSFET here conducts when everything is right. So when you put positive to positive and negative to negative, this conducts, and when you reverse polarity, it doesn't conduct. So this is how it protects against reverse polarity. But what is funny here is that we have also a Schottky diode which kind of acts the same. I don't know why they made this. I couldn't help myself, and I took out the metal can holder that's surrounding all this section, so that I could reach more in here. And I found an interesting thing. DJI decided to place also a TVS diode, which is a short for transient voltage suppressor. Is actually a device that clamps down spikes or voltage when you reach the limit. This TVS diode is rated for normal operation 22 volts, and it starts to clamp at 35. It is not recommended to work over the working voltage, which is 22 volts in this case. There is one for 26 volts. So for any of you that want to install the air unit without a regulator, you might think of getting rid of this part or just change it if you have the means. It will not break while using it on 25 volts, but it is not recommended. Yeah guys, so this was my take and teardown of the DJI HD FPV system air unit, and my thoughts, well, it's a pretty nicely done piece of gear. Obviously they repurposed a lot of parts and things they use on normal drones. I hope you guys learned something today. Don't forget to press that subscribe button if you enjoy this, and till the next time, bye.